Personal finance practice problem using Excel. Annuity initial investment calculation using the present value of annuity calculation. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, going to populate that into the blue area on the right side. We're looking at the general type of scenario where we are thinking about wanting to have enough money in an investment type of situation so that we can be taking money out on a periodic basis and thinking about having a fixed rate of return for the money that is still in the account. Now, this is often one that's going to be more difficult for us to visualize as to which tool we should be using for this type of calculation because it's something that looks like an annuity and is an annuity, but it's something that we're kind of planning for to be happening in the future. So we might think it would be like a future value annuity type of calculation, but in reality, it's going to be a present value type of calculation because what we're trying to do is look at the series of annuity payments from a present value standpoint, bring it back to the current date as of this point in time. Think about how much money we would have to put in at this point in time in order to pay out that annuity portion. So let's see if this makes sense here. Here's our information. How much would have to be invested to be able to take out each year $500? So we want to take out each year $500 for 7 years, and the amount that's still in the account we're going to assume is going to be accumulating a 7% increase. So this would be a type of thing you might do when you're doing like retirement planning or something like that, and you're trying to think about how much money do I need if I was to take out so much per year, and the amount that I still have in there is going to still be increasing upwards. So that kind of scenario, you might have other scenarios in a similar type of situation if you're planning for something that's going to result in a series of payments that's going to be happening at some future point. So, okay, we're going to do our present value calculation. Let's start it off with a present value of an annuity in an Excel function type of format. Then we'll prove that by basically running the table, which is often a great tool to kind of verify that we have our mind wrapped around this thing. So we're going to do a present value of annuity calculation equals the present value. It starts off the same as the present value of 1. You can double click on the present value or shift 9. There is our function argument. We're going to pick up the rate, which is you could type in there at 0.07. I'm going to point to the cell at the B6 for the 7%, comma, number of periods. Number of periods is going to be 7. So I'm going to scroll down, down, right, down, down. I'm going a little bit faster in Excel as we get used to our using Excel, hopefully, at this point. So then I'm going to say comma again. This time we are using the payment because this is an annuity calculation as opposed to the present value of 1, in which case we skipped the payment and went to the future value. In this case, we have the payment of 500. We're imagining that to be repetitive payment, not just a one-time payment that will be increasing by 7%, but one in which case we would be putting it in, each period. So then we're not going to have any future values. So I'm just going to leave it there and enter. And there we have it. Let's increase the size of this a bit. We're at the 2,694. Let's make it a positive number by double clicking on it. We can put a negative in front of the payment, which is probably more proper. I like to put it in front of the P here. So there we have it. So we're at the 2,694. Now, you might have thought, well, if I would need 500 times 7 would be the basic calculation, that you would need 3,500. But of course, you don't need exactly 3,500 to be taking out 500 each year if the return is getting 7% return. So then the next step is to say, well, I don't know, let me double check that this number is correct by basically running that number in our running balance type of calculation over here. And if it's correct, if I start at that investment point here, take out $500 each year, then am I going to end up at 0 at the end of this time period? That's kind of what we're looking for. To see these two things side by side, let's go ahead and hide some columns here. I'm going to put my cursor on column D, drag over to column F, D to F, and right click and hide those columns. And let's do this calculation again. I'm going to say 0, 1. I'm going to copy that down to line 7, highlighting those two or selecting them, putting our cursor on the autofill handle, dragging down to 7. Then we'll go to the Home tab, Alignment Group, and center it. And there we have it. Now, I'm going to recalculate the investment again, doing that calculation again just to practice it. Negative present value, shift 9, the rate, left, 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 down, 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 7%, comma, number of periods, left, 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 down, 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 7, comma, and then the payment, left, 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 down, down to the 500, and enter. So there's our 2,695 about. We're going to say that that's going to be an increase for whatever the value is that we're increasing it for. So if it was a savings account, it would be interest. If it was stocks, we're going to say the value is going to go up. We're estimating by 7% and so on. So I'm going to say this is going to be equal to left, left, up, 2,695 about times the 7%, and enter. Now, I'm not going to copy it down yet. I'll do a couple of these calculations and then we'll copy it down and I'll go back and make the absolute references needed to do so. Then I'm going to make it a negative for the payment. I'll make it a negative here for the payment of 500 because we're going to take out 500 each year. That's the point. And at the end of this, we should end up at 0 if everything worked out the way it's supposed to. So this cell we could be say equals the investment, the 2,695 plus the 189 minus the 500. But because I put it in here as a negative, I'm going to say plus the negative number, which will be a subtraction problem. So the 2,695 plus the interest earned minus the amount of we're going to be paying out in the annuity. And there we have it. Now, I think it would be better to calculate this one. I'm going to delete that this way. This equals the one above it plus the sum of, and that the fact that this number is negative allows us to do that nice sum function of these two, closing up the brackets and enter. Let's do it again. This equals the 2,383 times the 7%. And then this is going to be the negative of the 500. And then this is going to equal the amount above it plus the SUM, sum, shift 9, left arrow, holding down shift, left again, holding down the shift and 0, and enter. There we have it. Let's do it a couple more times. This is going to be equal to the 2,050 times the 7. And then 500 negative at the 500. And then this is going to be equal to the prior balance plus the SUM, the sum, left arrow, holding down shift, left, shift 0, closing up the brackets, and enter one more time. And then we'll do the autofill, doing it the easy way then. Take this item times the 7%. This is going to be equal to the negative 500. This will be equal to the amount above it plus the SUM, shift 9, left arrow, holding down shift, left again, and enter. See, I didn't close the bracket up and it gave me a little error, but that's okay. Then it fixed it. So there it is. So now let's delete it and let's do it again as if we're going to copy it down. I'm going to delete these and do it again as if copying it down. This equals this 2,695 times the 7%. And then the payment is going to be the negative 500. And then this is going to be equal to one above it plus the SUM, shift 9, left arrow, holding down shift and shift 0 to close it up. Now, if I copy that down, selecting these items and using the autofill to copy it down, then we'll see what the problems are. So this problem here, it moved the 7% down. So we want to fix that. And this one got moved down from the 500 down here. So those two we're going to fix. So I'm going to delete these. And I'm going to fix it by double-clicking. And anything outside of our table, that's usually what we need to fix. So this is in B6. So I'm going to put my cursor in B6, say F4 on the keyboard to put a $sign before the B and 6. You only need a mixed reference, but an absolute reference works. And then I'm going to put my cursor here, double-click on the 500. Once again, select F4 on the keyboard, $sign before the B and the 4, saying Excel, do not copy that down, and enter. Now let's copy it down again. I'm going to autofill it the whole way down this time because I'm confident. I'm confident that we did it right this time. So there we have it. And the bottom line number gets to 0, indicating that, yes, indeed, this is the proper amount that we calculated. So you can see how that kind of worked. And then if I double click on this last one, we see, yes, that's doing what we expect it to do. Everything is doing exactly what it's supposed to. Okay, so now let's do this with a formula then. Let's do the present value of an annuity with a formula. So I'm going to select the cells from, let's go from C to K here. No, I made B larger. I didn't want to make B larger. I want to go from C to J. CJ, let go, right click and hide those cells. Now let's do this with our present value of an annuity calculation. So here it is down here. This is a long kind of formula. If your instructor or someone forces you to do this, they're kind of mean because it's kind of a long formula, but they might, and it might be worthwhile just to kind of look it over to get an idea of what it looks like. Again, in practice, of course, you'd probably be using the Excel worksheets, and I think the running balance, those combination between those two, will actually give you the most insight for what you're normally going to be using these for. All right, so we're going to start here with the payment amount. So P stands for the payment amount. Obviously, you can plug this into this formula. The payment would be the 500 times the 1 minus 1 over 1 plus R, which is 7%, to N, which is going to be 7 years, divided by R, which is 7%. I'm going to break this out into a table format, which I think is good practice just to do and just to build tables with, kind of like a tax return format. And we know that financial statements are similarly formatted. Notice this one is a long, ugly formula with multiple different division components to it, and therefore we're going to have different subcategories. You might set it up a little bit differently if you were to set up a table, but just practicing kind of putting a long formula into this kind of table structure actually is fairly useful oftentimes in practice. So I'm going to say, all right, the 500, my major thing is these two components. I want to put these on the outer side, outer column, and then I'm going to bring a whole nother inner column for these two. And then this numerator, I'm going to bring even further inside for a subcalculation, given the more detail there. All right, so the payment's going to be 500. I'm going to say this equals the 500. And then I'm going to call this the numerator, which is not an exact item. I could actually, list out the numerator, but I'm going to call this the whole numerator up top. And I notice it's 1 minus this whole thing. So I'm going to put down here just 1 in this inner column, because once I'm done with this numerator, I'm going to want that to fall out into the outer column. And then I'm going to call this, and I know this is kind of a convoluted item here, but it's going to say numerator 2, which I'm going to indicate as this 1 right there. So I'm just going to indicate that as 1. And I'm not going to put a colon because that's just going to be the 1. And then I'm going to say the 1 plus R to the N, which is the denominator of this higher little component here. So I'm going to say this is going to be 1 plus R, shift to the caret, shift 6N is going to be then, I'm going to put this on, and I'm going to put a colon on this one because I'm going to bring into the inside again. So this is going to be 1. The rate is going to be then the 7%. So let's call this just the rate. The rate is going to be equal to the 7%, bringing that into the inside. Let's make that a percent. Go into the Home tab, Numbers, making it a percent. Font group, and then underline. I'm going to call this a subcalculation. So this is a subtotal. And I'm going to use the trusty sum function equals the SUM, shift 9, up arrow, holding down shift, up again, and then closing that up, making that a percent. Home tab, Numbers, percentifying it, 107%. Then I'm going to take that to the power of N. So I'm going to say this is going to go to the periods N, period N periods, in other words, which is going to be 7 periods. So this is going to go to 7 periods 7. And let's underline that by going to the Home tab, Font group, and underline. And that's going to be this whole subcategory calculation, which was 1 plus R, and then shift 6 to the N, which I'm going to put in the outer column now. So now we're pulling this to the outer column. This is going to be equal to the 107%, shift 6, caret to the 7 power of N. Let's add some decimals there. We're going to go to the Home tab, Number group, and decimalize it, just adding a whole bunch of decimals. And so there we have that. And then we could indent this whole thing. Let's go to the Home tab, Alignment, Indent, and indent this whole thing. Home tab, Alignment, Indent, and then indent this one again. Home tab, Alignment, Indent. And so there we have that. And then we've got, I'm going to call this a subtotal, subtotal, which is going to be this whole thing right here. And I'm going to pull that into the outer columns, put an underline here, font group, and underline. And now I'm going to subtract this column here. So subtracting this out, notice I'm only doing something to the left or right above in our calculations. This is going to be equal to the 1 divided by now the 1.605 and so on. Adding some decimals, Home tab, Number group. Let's decimalize that number. So it's been decimalized. So there we have that. And then we can pull up the denominator. Then we can get the full numerator. So that this is going to be the numerator, which is going to be this whole thing. Now 1 minus that thing. I'm going to underline here. I'm going to go to the font group and underline. Subtract this out. Notice I'm in the same column. This colon might indicate that I could have one more column, but we'll do this in the same column. This is going to be equal to the 1 minus the 0.622750. Adding some decimals there, home tab, number group, decimalizing. So there we have that. And then we can take the denominator, which is R here. So that's going to be the rate. So let's take the denominator, which I'll just say, let's call it denominator or the rate. And that, put the brackets around that. That's going to be equal then to the 7% again, 7%. Making that a percent by going to the home tab, numbers group, percentizing it, font group, and underlining it. And then we have our subtotal here. Let's call this a subtotal. And we'll bring that to the outside. And we'll divide this out. This is going to be equal to the 0.37725 and so on, divided by the 7%. Making that a percent, or adding decimals, home tab, numbers, decimalizing it. So there we have that, and that'll give us the present value of the annuity finally by taking this component times this whole thing here, underlining this one before we do, home tab, font group, and underline, multiply this out. This equals the item way up top, 500 times this 5.389, and so on. Adding a couple decimals there, home tab, numbers, couple decimals. So there's our 2694 once again. So again, I know that was kind of a long table type of worksheet and whatnot. So if you were to calculate this in practice, in a test question, it can be kind of cruel, again, to make you do that multiple times. And the Excel functions are useful to do that. And of course, you can plug this into the formula here as well. So I'm going to hide this. Let's look at the tables now. I'm going to hide from L to Q. Right-click on the selected area and hide those cells. And let's do this with the trustee table. So we're going to say the payment is going to be equal to 500. Now make sure you got the right table. We're talking about the present value of an annuity table. And once we have that, we're simply looking for 7 and 7%, 7 periods or years, yearly percent, yearly years and periods. This is going to be 7 and 7, 5.3893. So 5.3893, adding decimals, home tab, the number group, add 4 decimals there, and this is going to be from the table. And let's underline this by going to the home tab, font group, and underline. And this will give us the present value of an annuity. Let's just keep it annuity. This will be equal to the 500 times the 5.3893. And we can add a couple decimals there. And there we have it. Let's unhide a few tables here, or unhide some of these columns, and then just recap what we've got. Unhiding, we're going to put our cursor from R column to B, right-click on the selected area, and unhide. And then we can see that we got this calculation at the 2694 with the present value of an annuity. We double-checked it by starting there and then having the annuity payments ending at 0, which gives us verification that it was done properly. We then look at the present value of the annuity. We get down to that 2,694 as well, noting that this amount is in essence the amount from the table. This is the amount that you could build the table from. It's more than 4 digits long, which means we have a slightly different number here, the 2694.65, very close, but slightly different due to the table's rounding to 4 digits.